Hello student, today I am going to discuss about the adjoint of a matrix. Now the adjoint of a matrix is denoted as adjoint of A. Actually the motivation of adjoint of a matrix is to compute inverse of matrix A. This kind of computation in mathematics we use adjoint of a matrix. Okay, now let's assume a matrix A equal to A11 A12. We take 3 cross 3 matrix, then you can generalize this form, A21 A22. Okay, we take this 3 cross 3 matrix. Now how to compute the adjoint of matrix A. Adjoint of a matrix is given by, okay, just okay, this is capital A1 capital A2, and this A1 A2 is called the cofactor. Okay, and how this A1 A12 A13 is calculated? A11 is given by the determinant of A22 A23 A32 A33. Okay, similarly observe that how A11 is given by, take this A11 and remove this row, this column, remaining part A22 A23 A32 A33. Okay, we take this determinant here, and this should be the value of a capital A11. Similarly for A12, this should be the negative of, similarly, okay, this negative comes alternatively, negative determinant of A21 A23 A31 A33. Okay, this is the value of A12. So similar process, A12 corresponding A12, this is the corresponding row, this is the corresponding column. Remove this column, remove this row and this column, the remaining part is this. So we take this as a determinant, and the sign should be alternative. That means when you take determinant, the sign should be positive negative positive. Okay, negative positive negative positive negative positive. So when you take this determinant, the sign should be alternative. Similarly for A13, you take this as the required determinant. Okay, when this A21, then the row and column should be removed, and then the remaining elements make a determinant. That determinant should be the equal to A21. So similarly I can write A13 this way. A13 should be positive, A21 negative, A22 positive. Okay, this way the sign will be alternate way. And the what is the cofactor matrix is given by A13 means what here is A13, that means this row this column remove, and the remaining part is A21 A22 A31 A32 A21 A22 A31 A32. The determinant value should be equal to A13. This way we can find the adjoint of A. Okay, here is one mistake, it is transpose should be here. Okay, this way we find the A1 A12 A13 this value, and then after putting this value we make this matrix to transpose matrix, then it should be equal to adjoint of A. Okay, let's take an example. A equal to 2 3 1 4. Okay. I already told you that the adjoint of a matrix is given by a11, a12, a21, a22, and its transpose. Okay, now a11 should be given by the determinant of remaining part, so 2 is here. Okay, small a11, the remaining part, remove this column, remove this row and this column, then the remaining part is 4 here. Okay, so what will be the sign here? Positive 4. The okay, the value of a11 should be 4 because of the determinant of one single element is that element. Okay, now a12, what will be the sign here? Negative sign here. So remove this row, remove this column, the remaining element is 1, and the determinant of 1 is 1. Okay, in this similar way, a21, the value of a21 should be negative. So 1 3 negative 3. Okay, observe that the sign, how to sign is calculated. Okay, okay. You may think about that positive negative, that should be again in positive, not positive negative alternatively. Similarly, the column wise positive negative. So a1 on positive, this should be negative, and if the remaining element comes, then positive negative alternatively. Similarly, this is negative, and if the remaining in this column way, this should be positive negative, similar way. Okay, and this should be positive here. Okay, so a21 should be negative, and the determinant of the remaining cofactor, we call this cofactor, remaining element is 3 here, so the remaining element is 3. Similarly, a22 should be positive with, okay, 4. This row will be removed and this column will be removed, the remaining element determinant is 2, so 2. So what will be the matrix becomes, I write here 4 minus 1 minus 3 and 2, and it transpose. I already told you how to calculate transpose. It is nothing but make each row or make each column to row. Okay, so we take this column, now we have to make this column to a row. 4 minus 3, make this column as a row, minus 1 2. This is our required answer, adjoint of matrix A. Now I'm going to discuss about the inverse of a matrix. Now inverse of a matrix, before going to discuss about, always try to focus that when we finding the inverse of a matrix, the matrix should be always square matrix. Okay, then what is the meaning of inverse of a matrix? Let us assume, let A be a matrix. Okay, now we want to find the inverse of a matrix A. It is denoted as A inverse. Okay, what is the properties of the inverse of a matrix? When we multiply A with A inverse, it should be become I. That means it is identity matrix this give us. Okay, similarly, if we multiply A inverse with A, that give us also identity matrix. Okay, so how to calculate this inverse? And okay, the inverse of a matrix is given by adjoint of a matrix A divided by determinant of A. Okay, this way to I can find the inverse of a matrix. Now you can say that how to calculate the determinant of a matrix. Okay, determinant of a matrix. First, I give you some motivation. The determinant of a matrix is a key concept in linear algebra to solve system of linear equation and also matrix inverse. Here is the matrix inverse. Okay, and also linear transformation. You can learn in okay in sometimes later, and also eigenvalue, eigenvector, calculate area. This kind of field in determinant is used. Okay, then how to calculate the determinant of a matrix? Just observe that let A be a matrix A, B, C, D. Okay, the determinant of A, I give you the calculation part only. The determinant of A is given by A multiply D minus B multiply C. Observe that. Okay, now I take 3 cross 3 matrix, then you can understand better way. A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, this is 3 cross 3 matrix. Now we want to find the determinant of A. The determinant of A is denoted by like a mod A, or in this way, determinant of A, or this is same as determinant of mod A, like that. Okay, now how to find the determinant of A? A1 with multiply with determinant of B2, C2, B3, C3. I already discussed about the how to calculate this determinant. Okay, okay, in this way, that means B2 C3 minus B3 C2. Okay, similarly, the when in the second part, minus B1 A2 C2 A3 C3. Okay, plus C1. Alternative way we can change this sign. Okay, A2 B2 A3 B3 here. Okay, and you can calculate this term by term, then you get the result, determinant of A. Like I can write this. Okay, observe that we already discussed about the determinant of 2 cross 2 matrix. Here it is the way or formula for this to find the 2 cross 2 matrix determinant, and I write this only. Okay, this calculation or this answer or this expression should be the answer of determinant of 3 cross 3 matrix. Similarly way you can find 4 cross 4 matrix, 5 cross 5 matrix, but in the real case maximum 3 cross 3 matrix we need our need. So observe that how to find the determinant of a matrix. Okay, okay, now our determinant of a matrix have some property. First properties, here I write determinant of two matrix. When we multiply with two matrix, then we take the determinant of two matrix is equal to determinant of A with determinant of B. That is the first property. Second property, if we change two column. Okay, here it is the for example, take an example for this case, 1 2 2 1 0 1 1 1. Okay, the determinant of A, this is take A and this is take B. Determinant of A 1 minus 4 minus 3. Determinant of B 0 multiply 1 0 minus 1 minus 1. Okay, and the AB matrix should be 1 2 1, sorry 2 1 and 0 1 1 1. Okay, if I multiply this way, 1 0 2 2 here, 1 2 as 3 2 1 1 2 1 3. Okay, I get the AB matrix. Now I want to find the determinant of AB. It should be 3 2 or 6 minus 3 equal to, okay, maybe I, okay, no, it's right, 3. Okay, 3 we can write minus 3 multiply with minus 1, this should be 3. Okay, what is the value of minus 3? It is the determinant of A into determinant of B. Okay, I prove it. Okay, now second property is this: if two column interchange, then determinant is multiply by 1. If two column or two row, one of is interchange, then determinant is given by multiply 1. Determinant is equal to, it should be equal to negative of, that means multiply by 1 into determinant of A. Example, take A equal to, similarly I take example 1 2 1 2, the determinant of A 1 minus 2 equal to minus 1. Okay, now I give you the information. If two column or two row is interchange, like I want to interchange in this way: A dash is the new matrix with interchanging two column, second column make first column and first column make second column. Okay, and now find the determinant of A dash. 2 minus 1, it is equal to 1. Observe that it's, the value is, modulus value is almost same, but what is the changes? The sign will be changes, negative with multiply. That means it is the minus of minus 1. We can write 1 as a minus 1 into minus 1. So minus 1 into determinant of A. Okay, I prove this result. Okay, now the third property is, okay, now third property is determinant of K should be equal to K to the power n determinant of A, if A is the matrix of n cross n matrix. Okay, now how to prove this result? First of all, okay, 2 1 2 3 4, take this matrix and 2 4 6 8, our matrix properties, when we multiply a scalar then it should be the result. Okay, then I want to find the this determinant of this. Okay, what would be the result? 16 minus 24, that means minus 8. Okay, now we want to prove that this should be the equal to this. For here, what is the value of K? K equal to 2 here. So that means, what is the, I am finding this this value K to the power, what is the value of K? K is 2 here. What is the value of n? N is 2 here because of it is 2 cross 2 matrix. Okay, so 2 to the power 2 and determinant of A. And what is the value of determinant of A? A equal to 1 2 3 4. The determinant is 4 minus 6 equal to minus 2. So what is the value of this? 2 to the power 4 into minus 2. Sorry, 2 to the power 2, sorry. 4 into minus 2, it should be minus 8, and both are equal. Okay, this is the important result. Third property is, if two rows or two columns are identical, that means they are identical, then the determinant should be 0. If two rows, take 3 cross 3 matrix, 1 1 1 1 1 1, and this may be 2 4 3. I told you that if two rows or two columns are identical, here two rows are identical, then the determinant of A is 0. That matrix should be 0. Now I give you the definition. Now we want to check the determinant of that matrix. Okay, I write the definition. If two rows or two columns are identical, then determinant of that matrix should be equal to 0. Okay, now I calculate this determinant of that matrix. The 1 3 minus 4 minus 3 minus 2 plus 4 minus 2. Okay, what is the value of minus 1? Minus 1 plus 2. Okay, it should be 0. I proved that result also. Okay, and another is result is, the determinant of transpose of a matrix is equal to the determinant of that matrix. Okay, uh, if you check this result in your way, okay, and also you can give an example, then you can verify that result also. The sixth property is, I already discussed about the adjoint of a matrix. Adjoint of a matrix A, if we multiply with A, this should be equal to A with adjoint of A. Why this property? Because we know that all time A B, not always B A. This is not always. But observe that when we find adjoint of a matrix, treat as B. But what is B here? In this case, adjoint of a matrix A with multiply A should be equal to the A dot multiply with adjoint of A. That means they are commutative. Okay, for all cases. Here is the property, and the second property is adjoint properties. Sorry, seventh properties. Adjoint of AB should be equal to adjoint of A multiply with adjoint of B. Here is the seventh property. If you take adjoint of AB product, then it should be equal to the distinguished product. That means when you take adjoint in the individual case, that should be equal to. Okay. Okay, I already discussed about the determinant. The another properties, here it is. If AB equal to 0, I in previous video I already give you that property, that if AB equal to 0 does not imply either A equal to 0 or B equal to 0. This cannot always true always, but in the case of determinant, if this hold, okay, then the determinant of A and the determinant of B should be equal to 0. Observe that when we have this situation A B equal to 0, this cannot imply either A equal to 0 or B equal to 0. Both can be non-zero. Okay, but in the case of determinant, the determinant of both matrix should be 0. Okay, here is the all properties of the determinant and adjoint of a matrix. Now we further go to the inverse of a matrix. Now I discuss about the adjoint of A and determinant of A. I already give you the brief discussion in determinant and its also properties there. So in this way you can find the uh, inverse of a matrix. Okay, observe one thing. If determinant of a matrix, or this is denotation, equal to 0, then inverse exists or not. Okay, inverse cannot exist because in the formula, observe that this become or not. And when you get a form 1 by 0, this become a infinity form. That means this is exists or not inverse. A inverse does not exist. When determinant is 0, that means the inverse does not exist. Okay, so the necessary condition of to exist the inverse of a square matrix is determinant must should be not equal to 0 to existence of inverse of a matrix. Okay, this is our observation. And also inverse of a matrix have some properties which is you can calculate in your own. Okay, you take two matrix which are invertible, and two matrix invertible means determinants must should be not equal to 0. I already told you that to exist inverse of a matrix, determinant must should be not equal to 0. Okay, the AB whole inverse if you take, then it should be equal to B inverse A inverse. In the case of transpose, I give you the, okay, sorry, 1 minute, sorry, adjoint, not transpose. In the case of adjoint, here is the property: adjoint of AB equal to adjoint A adjoint B. But in the case of inverse, here is it is the way to remember these things. When you apply inverse, then B inverse A inverse should be reverse. Okay, and you can verify that in your own, but one conditions you should remember, that A B both must be invertible. That means the determinant of A not equal to 0 must be, and determinant of B not equal to 0 must be. Then this property can satisfy. Okay, another property which is, if we take the transpose of a matrix and take then inverse, it should be equal to the inverse then transpose. You can either way, either take inverse first then transpose, or you can take transpose first then inverse. This is the all properties of the inverse of a matrix. Okay, so today I discuss about the firstly I covered determinant of a matrix, adjoint of a matrix, how to find the adjoint of a matrix, determinant of a matrix, and also inverse of a matrix, and I discuss all properties. If you, I think if you have, otherwise it's okay. If you have any doubt, then you can comment below. So thank you.